All right, good morning. So here we are talking about differential equations again, and some of these problems are they're worded a little strangely, and sometimes what they're asking for isn't all that apparent. So I tried to go through them a little bit before, and it's like, sometimes it takes a little bit to figure out exactly what they're asking for. So we're going to go through this, but if you're looking at this like, I wasn't quite sure what they were asking, like, yeah, me either. So we'll just go through it and see what we get to. All right, so let's get here. So let's go to that. And here we are. So this one here, okay, says the rate of change in the concentration of a drug with respect to time in a user's blood, dc by dt is equal to negative kc plus dt, where the dosage is the time. Okay, so what we're doing is like here. So we have the change in the concentration, right? That's what we're looking at here. This is change in concentration. Okay, is equal to negative kc. So your experience with medications, experience with different, with pretty much anything you put in your body, the concentration of it is going to go down over time because we have a metabolism, right? So it's going to start processing whatever you put into it, whatever you put into your body, and the concentration in there it's going down. But we have a dt here where this is a dosage. So this is concentration is decreasing. Okay, negative sign. And then the dt is a dose. Okay, which means that's seeing this spelling of does, but dose. Okay, so we think about like if somebody is taking, if they're taking an antibiotic or they're taking something where they just keep giving, they keep taking more of this. Okay, as time goes on, you think about intravenous drip. Okay, that would be more of a continuous thing here. But if you're taking like an antibiotic pill every morning or every night, whatever, this would be a spike. Okay, but we don't really deal with that in this class. You have to take the actual differential equations, and it's only at the end, and these are a little bit difficult to deal with. Okay, so we have concentration is decreasing, but we're adding in more from whatever dosage we have. Okay, and they kind of set some of this up for us. There was a solve the linear differential equation to show that this thing is going on here. Okay, so the first thing they want us to do, we're going to begin by writing this because technically, like assume that we have some kind of a drip. So it's the drug is being processed and it's leaving the system, and then you are also adding some to it at all times. Okay, so a nice continuous model is what we're starting with. So what are they asking us to do? We're asking us to put it into the situation where we have like the first order linear differential equation. Okay, that's this form right here. Okay, so we want it as dy dt plus p of some value times y, okay, is equal to some kind of q of t. So all we really want to do here, dc by dt plus kc is equal to dt. Okay, that's what we want for that first little part. Okay, it puts it in a nice form. As long as we have things that are pretty well behaved, we'll be able to do this one. Okay, so dc plus, and then here we have kc, okay, for concentration, and that is equal to our dosage with time. Okay, oh, they're very nice about this. Okay, there's a lot of parts to this one. I'm so sorry. Okay, identify the PT in the equation. Okay, that's going to be K. Okay. And QT, right, the one on the other end here, that's going to be our dosage. Okay. Find the integrating factor, e to the, right, whatever PT was. So we knew that PT, right, that was equal to K. So we're going to have an integrating factor, e to the integral K dt. which eventually is going to be e to the kt. Okay, let's see what happens with that. Find the integrating factor is equal to e to the kt. Okay. Excellent. Okay, what do we have next here? Multiply each term by the integrating factor. So we have dc by dt times e to the, I don't know why they're making us do this. It seems like, wow. What do we have here? We have k, oops, wrong one. Yeah, k e to the kt, okay, times y. Okay, and that is equal to, oh, well, thanks. Okay, we wouldn't have done that any other time, but thank you. All right. Oh, at least one of your answers is incorrect. Sometimes it is hard to know exactly what they were looking. So you're like, this is unpleasant. I absolutely agree. All right. So we have e to the kts, e to the kts, e to the kts. Not seeing anything here that's right. You have to do this thing to everybody. We'll check again. Let's see what the heck they want. I know I'm wrong. Okay, this is one thing to say. I don't know what you're doing. Multiply each term by the integrating factor. We have our integrating factor. We have this thing. We have ky e to the kt is, I do not know. I don't know what I'm telling me. What did I not do? Oh, C. I used the wrong letter. I'm sorry. All right. Replace the sum of the terms on the left-hand side with dt integrating factor c, substituting everything. Okay, so what I was trying to say is that this is the derivative of that product rule that we always collapse this thing into. Okay, so that's what we're doing here, is we're just collapsing this into that product rule. So we want the d with respect to t. Okay, so the derivative with respect to t, and this is going to be c e to the kt. Okay, that's what they want there. And on the other side, okay, substituting the expression previously found for IT. Okay, so they, oh, again, they just want us to type this in. Okay. I think that should do it. All right. Okay. Next, integrate both sides of the equation. All right. Okay, so here, I think all they want us to do is, here we've got this derivative. I'm not entirely sure what they want us to do, but they want the derivative of c times e to the kt, okay, is equal to the integral of dt, okay, e to the kt. Okay, I think that's what we want. But if we integrate this, this is going to be c times e to the kt, and I don't think they want us to mess with this yet. So what must be multiplied to get c by itself? That would be e to the negative kt, because eventually we're going to multiply both sides by this in order to free the concentration to be by itself. And to do that, we have to divide by e to the kt. That's how we write the negative exponent there. Okay, what is the final step to integrate to get to the right side of the equations? Oh boy, we're not, oh, find the bounds to be t, 1 to y, okay. 0 to y. I like this one a little bit more. It's the dummy variable t because we're integrating with respect to t. I think this is what they're wanting us to do here, because notice that this differential up here, this thing up here is we're integrating with respect to y. Okay, on that side. So we are going to be using the dummy variable y. We're going to go from 0 to t. All right. Okay, show that if d of y is a constant, then c of t is equal to this thing. If d is a constant, we take it outside the integral sign. So yeah. Okay, so if t is equal to this, then show, I think we could just say c of t is, I'm wondering if it's a constant. Can we just say it's going to be like a or something? In the equation. How about we just use dosage for d? Okay, we'll just do that. Yes. See, I would really like to call that, use d here, because that's what came out of this integral. Okay, that is what came out of this. So what if we do this? What if we just okay. So what if we just integrate from 0 to t e to the k y? Okay, because that looks like what they're doing here. Okay, we're trying to integrate e to the ky, and let's just see what happens. So if I integrate this thing, okay, with respect to y. Okay. So like I said, by the way, I would never ask you guys a quiz question like this. Okay. So we're just trying to go through what they're trying to guide us through to see what they're trying to make us see. All right. This would be a very poor quiz question, because what are we looking for? And I pretty much have to like deal with the breadcrumbs that they're handing out in a piecemeal way. I don't have an idea of what they want here. Okay, so this is going to be e to the ky times k, right? And we're going from 0 to t. Okay. So if I take this derivative, I want 1 over k, sorry. If we take this derivative, okay, we get e to the ky times k. So integration, if I take that integral, I should be able to get this. Okay. I'll get back with what I started with. Okay. So we have 1 over k times, we have e to the kt minus 1. Okay. So for some reason, they decided we really wanted to put in a negative here. Okay, we're going to want, okay, so let me let the equation show that. They're saying that d of y here, this is a constant. Oh, you know what? Oh, this is what they're going to do. We're going to pull this out. I think they want this e to the negative kt on the outside. Since we're integrating with respect to y, that t is not going to matter. So I think they want d e to the negative kt. That's what they want here. All right. Oh, very good. Lucky guess. Sorry. Okay, integrate the integral with respect to t. So what did we do? Right? We integrated this e to the ky. And we did that. Okay, so that's 1 over k. Oh, okay, we haven't evaluated yet. So we're looking at what the integral is. So this is going to be 1 over k, okay, e to the ky. I think that's our integral from this thing. Okay, we're going to evaluate next. Check your calculations. Did they want the beginning of this thing? Did they want dE to the negative kt times this thing? Go figure. Okay, I'm sorry. I really am sorry that they are dragging us through this without any. I mean, it's hard to tell what do they want. Now we great with respect to the t and simplify. The other thing is I like to wait to put this thing on the other side until we're done. Okay, so we have so we have our integrate. We have our little part here. Okay, here's our part, and now they're going to want us to multiply. So we've got d e to the negative kt times all of this. Okay, so we're going to have d over k. This is going to be, when the bases are the same, right? We add the exponents, so that's going to be a 0 in the exponent, so it's going to be a 1 minus e to the negative kt. Okay. So let's see about that. D over k, 1 minus e to the kt. Let me double check to make sure my sign is correct. Nope, I'm going to negative up here. Otherwise, it's going to tell me. All right. And parenthesis, nope. Ah. There you go, in that parentheses. Simplify your answer. Oh, okay, there we go. Next question. Oh, that was it. That's what they wanted. All right, go figure. Terrible quiz question. Would not do that to you. Okay. This one. This is looking better. We'll use the population growth model, where y is a population at time t, and f of t is some other function that describes the net effect of immigration and emigration. Choose k is equal to 0.03. Okay, so look at this. They've actually done this for us. Thank you. We don't have to set up a model. So the change in population is equal to, like, it's proportional to the population. I know that most of the time we do this with humans, but you know, the idea that dy by dt, this is our basic population model. The change in bunnies is proportional to the number of bunnies that we have. We know what bunnies do. Okay, but in this case, we're saying that this is our immigration factor. Okay, so the change in population is proportional to the number of bunnies we have, plus / minus the number of bunnies that come in or out. Okay. So write the equation in the linear form. Okay, we could do that. So what we're going to do is we're going to move the k to the other side. Okay, so what we're going to have here, we have dy by dt is equal to 0.03 y plus f of y, or f of t rather, f of t. So dy by dt minus 0.03 y is equal to f of t. That's the standard form we have here. Okay. So oh, and f of t is equal to e to the t. So that's okay. E to the t. All right. I'm kind of like an A. Okay, because we want the p of x over on the left-hand side here. I would not want this. What are they doing? At least it's not the last problem. So solution, we have to solve this thing. Okay, thanks, guys. All right, it's not like we didn't solve a ton of these before. So integration factor, we have e to the negative 0.03 dt is equal to e to the negative 0.03 t. Okay, we're just integrating this thing. Do not put the y up here, okay? So it's q, oh no, it's p of t times y. The integration factor is e to the integral p of t. Y has nothing to do with this at this point. Okay, so please do not put the y up here. Okay, so we're going to go ahead and integrate, or we're going to go ahead and multiply by our values here. Okay, so we have e to the negative 0.03 t times dy by dt. Okay, and this is equal to, minus 0.03 e to the negative 0.03 t times y. Okay, and that is equal to, on the right hand side here, we have e to the negative 0.03 t times e to the t. Okay, so we're going to go ahead and say this is the derivative of something. It's the derivative of negative 0.03 t times dy, or times y. I'm not taking the second derivative, just one, it's plenty. Okay, so times y. Okay, and that is equal to the other side. We're not been integrated yet, but I do want to simplify that because it is possible you can get an integration by parts problem on the right hand side. Sounds like it would be a great final exam question. But what we're going to do is we're just going to add, right? The bases are the same. We are adding the exponent. So 1 minus 3, right? You have $1, take away 3 cents. Okay, and that's what we're going to have there. All right. So go ahead and integrate. This one's easy to integrate. This is e to the negative 0.03 t times y is equal to e to the negative, or e to the 0.97 t times 1 over 0.97 plus c. All right, don't forget the c because that's going to be an important thing here. Okay. And after that, I think if we just multiply by e to the 0.03 on both sides, e to the 0.03 t on both sides, all right, we are going to get rid of this. So we have y equals, okay, what is 1 over 0.97? Oh, you know what? 0.97 is equal to 97 over 100. So why don't we take the reciprocal because it's 1 over. So we have 100 over 97. Okay. E 0.03 plus 0.97, that's just going to be 1. Okay. Plus C e to the 0.03 t. There's no combining these because while the bases are the same, we have a plus in between them, and it's different than the fact that we had times before. Okay, so we have plus, we can't really do anything with this. Right? And then what's the last thing well, we're not quite done, but we're close. Okay. So what we're going to say at this point is when y was 0, when time is equal to 0, the initial population was 14,000. Okay. So when t equals 0, our y is equal to 14,000. Okay. You know what I'd really like to do? I'd like to say y is in thousands. Okay, so I'd really like to say y is 14 in times 10 to the 3, okay, in thousands. Okay, rather than have all those numbers. E to the 0 plus c e to the 0.03 times 0, that's 1. That's 1. I don't want to take the chance of getting that wrong. We'll go back to 14,000. Okay, so we have 14,000 is equal to 100 over 97. Okay, plus C. So we have 14K minus that is equal to C. All right. So we have, let's see here, we have 14,000. Okay, minus 100 divided by 97. Okay, great. And that is my C. So this is 13998. Well, 13999. We'll say 13999 is equal to C. Okay, give or take a couple of dozen people here, or a couple of dozen organisms. I have no idea if these are people, foxes, or goldfish. I don't care. All right. The solution is, round to the nearest hundredth. Okay, so 0.97. Okay. 13,998.97. Okay. All right. So y equals, okay, so this is 100 over 97 e to the t, okay, plus 13,998 right, 998.97. E to the 0.03 t. Fingers are crossed. I mean, I love how, like, here, do this one-step problem. Okay, now do the rest of the steps and hope all your arithmetic is right. And like it. All right. I'm just going to go through this because we'll see what they'll see whether we wanted the answer or not. Isn't that what I wrote? Oh, they didn't like the fraction. Okay. 100 divided by 97. What is that? All right. Thanks. All right. So there you go. I think that's the end of this one, mercifully. Okay, so I'm going to go ahead and save this. And if you're wondering, like, wow, the last two problems were really a pain, like, I agree with you. Okay, this was not the most fun experience. So I'll let that go. A quiz question from this chapter would very well be something that we covered like in the first couple of sections or the first couple of questions. All right, something like this. This is a nice problem. All right, this is a nice problem. All right, so we'll stick with something like that. That's pretty tame. Okay, we have some applications coming up in another section, but this is a nice, very straightforward, good quiz question. Okay, those last two, not good quiz questions. All right, thank you, and we'll do the next section, the next video.